still do them. Okay, so I want to talk about something that is sometimes confusing for people. Before we get into the elastic, inelastic, and all of these collisions, I want to talk about lab frame versus center of mass frame. Have you heard of these before? The difference between lab frames and center of mass frame. This causes a lot of confusion to a lot of people. Have you seen this kind of picture before? General relativity, people who've taken quantum. Where this frame, say S, and there is another frame, S prime. Do you guys remember S and S primes? Do you remember being a little bit confused about them? I will show you that this is nothing to be confused about. This is very simple. Okay, one of the frames is at rest. The other one is moving. In general, when you will study relativity, S is the frame that they consider to be at rest. S prime is the frame they consider to be in motion. Think of you standing here, watching something happen here. Ooh. This is called an event. Something happened. Something blew up, something came together, something hit a car, walking, blah, blah, blah. Whatever. You can call it an event. Something happened here. Okay? Now, how does your point of view change? Depends on what frame of reference you use. If you are in the lab frame, you are this person standing here observing this happen. Okay? If you are in the center of mass, in general, you are in the moving frame. So the way I think of this, as if you were observing a collision. So here's a ball. Here's another ball. It comes and hits it, right? So if you were the person standing here looking at it, this ball is moving and that ball is moving. Yes? They both seem to be moving together forward, correct? In the same direction. This is called the lab frame. On the other hand, if you were the person that was sitting, I don't know, pick one. Let's sit on this. And moving with the ball, you would assume, if you didn't know any better, that the other ball was coming towards you. Do you see that happen? Is that going to be true? So you would think you're standing still and the other ball is coming and hitting you because you're moving with it. That frame of reference is called the center of mass frame. And this is very easy to see. So if you guys want to test this, maybe you guys could be particles colliding. Anybody want to do that? I think it might be a good idea. Can you guys, okay, Amanda and, okay, Zain, can you try that? So come on over. Sorry, move, yeah. Okay, so what we're going to do is, wait, hold on. Turn around. Okay, move slowly forward as he moves faster towards you. And then collide with her a little bit. What did you observe? What did you guys observe? You observed them both moving forward, but Zain moving a little bit faster, so he caught up to her, right? Okay, we're going to repeat this, and now we're going to look at your point of view. Come back. We're going to start from here again. Now you're going to try to go backward. No, turn around. Okay? Observe what you observed with him. And you're moving forward. Please be careful. Don't go too far. Okay? Come and hit her, right? And move back slowly. Okay, I got it. What did you observe? Did you guys just see her still moving backwards and him going forward that way? Both of them were moving this way, right? But what did you observe? She seemed to be coming towards you, right?
Yeah.
What did you observe? Do you see the difference? In the center of mass frame, each of them observed the other one going towards them. It doesn't matter who is going faster or slower. That's the difference between center of mass and lab frame. Got it? Anybody else want to try it?
So it's just perspective.
It's just perspective. That's why they're called reference frames.
Gotcha.
The lab frame is the one that's
You.
So we're
It's you that are the lab frame. You are the red little person on the S frame.
center of mass frame that are always moving.
In general, it's like you're sitting on the collision observing it happen, right? And again, remember, it's from your point of view. So for Zain, it felt like Amanda is coming and hitting him. From Amanda's point of view, it seemed like he was coming and hitting. But you guys observed them both going that way. Get it? And this is a very fundamental thing to understand. But once you understand it, relativity becomes easy.
Great.
And then we can put math on it. Are we good?
Mm-hmm.
Okay, and then for people who have seen this before and for people who have not seen this before, this is what the math will look like. Ready?
Oh.
Woohoo! And what you will see is this written out. Okay? So imagine if you were looking at, so this is where it gets complicated. This is the velocity between the event, say P, and the S frame. So this is PS. Get it? So if the event is P, point P, whatever we're observing happens at point P, this is the velocity of the event according to the lab frame, the one that's at rest. Got it? This is the velocity of the event P as observed from the S prime frame, the one that's moving. That's like you looking at Amanda. Okay? And then there is also a relationship between the lab frame and the center of mass frame, which is this blue line that I have over here, which is SS prime. Stare at it. It's not complicated. It's still the same. It's just a bunch of math. Okay, hold on. Let's start again.
It's just like the colors are right there.
Okay, I will try to make the colors match the picture. I'm going to take this person away. That's my S prime frame and that's my S frame, right? Event happened at point P. What's the velocity at which this event happened according to S frame, the lab frame, a person standing? Pick a color.
Brown.
Wait, what?
Brown.
Brown? I don't have brown. I'll do red.
Beige. There's beige.
I'm gonna stop listening to you guys. Is this true? This is the R moving forward, which gives me the velocities, which gives me the accelerations, right? I can call this as SP, the velocity of the event from S. There is also the velocity of S and S prime. Because one is at rest and the other frame is moving. So you have to account for the fact that the S and S prime frames are moving separately, correct? And then there is blue. Okay, blue. This velocity, VS prime P. The velocity of the event according to the moving frame. So far, so good? Now, do a little bit of geometry. What does that tell you? May I write VSP as VSS prime plus VS prime P. Oh, and vectors, right? They're all vectors. Should all be vectors. Do you see how that happened? That's all there is to relativity. It's frames of reference. It's who is doing the observing. The same event will look different depending on your point of view. So remember, lab frame is the one at moving or rest?
Yes.
Center of mass frame is?
Moving.
That's what you have to remember. Remember them colliding. Okay? You, the observers, are in the lab frame. They, moving, are in the center of mass frame. And your calculations change accordingly. But fundamentally, this is all there is to it. So when we write our collisions, in my lab frame, my collision will look like this. So now I'm going to do my lab frame calculation. In my lab frame, one particle, other particle, V1I, V2 initial, right? This is what they're doing. In my center of mass frame, the same two particles, but this will look like V1I prime, and this would look like V2I prime. Get it? You see the change? So where is the person sitting then? In the lab frame. Where should I draw my person? Somewhere here observing it? Where should I draw my person in my center of mass frame?
Right.
Sorry, oh, I had already started drawing it. But it doesn't matter, right? Do you see it? It will both appear like they're going towards each other. The thing to know is, will the actual numerical values of V1 and V2 change? No. If V1 is 3 and V2 is 4, they will remain 3 and 4. It's just from your reference frame, it will look like they're going in other directions. Make sense?
Where is that?
I don't know. I might have. I didn't do anything this.
Like straight up.
So,
And I literally told her.
just to confirm, because I couldn't find it down anywhere. Presentation's going to be 10 minutes long,
Yes, 10 to 15.
10 to 15. It's
Right.
okay if we have
Yeah.
like
Also,
5 minutes questions.
Yes, that is fine. So it has to be minimum of 10 and maximum of 15, but like between 10 and 11, 12 is great. You'll get, you'll be able to do questions. Yeah.
I emailed you